All right, so some quadratic equations do not contain a constant term. We're going to jump right into this and look at the first example. But for example, this one, we have 3x squared equals 4x. So there's no constant term, meaning there's no 10 or there's no 7. Everything has an x in it. There's an easy way to solve that. Yeah, so the last lesson we had what? We had an x squared term and a constant term. This term was missing in the last lesson, so we were able to just solve the equation. But when you have an x squared term, and this is actually called a linear term, meaning it has an x and no exponent, when you have those two things and it's missing a constant term, you can do the following. All right, here's another example. 9x squared equals 2x. So again, that doesn't have a constant term. And even down here, even though there's a bunch of terms, none of them are constant, meaning every term has an x in it. So that's the steps we're going to learn apply to when that happens, when there is no constant term. And there is another way to do this, but this is the easiest way. And it's funny because we're actually using this right now in pre-calc to find vertical asymptotes and fun stuff like that you won't get to learn until next year if you do take pre-calc. We have 3x squared minus 7x equals 2x plus 5x squared. So right off the bat, how do you know that this is, to apply the following steps, this has no constant terms. Everything has an x in it. So you can do the following. First step you're going to do is move everything to one side. By the way, even if it does have a constant term, you still move everything to one side. So even if you forget, yeah, because when you move everything to one side, there will be a 0 on the right. That is correct. So you subtract 2x, right, because it's positive here, so you subtract it, and you subtract 5x squared because it's positive. Somebody asked us yesterday, if it was negative, you would add it, okay? So just move everything to one side, and you can combine in the same step. Doesn't matter to me.
Like you could have made it already like 9x.
You can make it minus 9x, yeah, negative 2x squared, that's fine. I usually do it, well, sometimes I do it in a separate step. So, next step, you're going to group your like terms. So put your x squared terms together and your x terms together. Again, those are called linear terms. So there's your x squareds and then your x terms over here. We get everything grouped. Now we can combine it. Again, you can do steps 1 through 3 in the same swoop if you want. It doesn't matter to me. But 3 minus 5x squared gives you negative 2x squared, and negative 7x minus 2x is negative 9x. So now you can start to see everything simplifies down to one term that has an x squared and one term that is just an x term. Again, no constant terms. So once you combine like terms, then you're going to pull out a GCF. That GCF will be x, okay? At least an x. Now imagine if this was a 3, you could also pull out a negative 3x, but this is just negative 2 and 9. Like I said, the least you can pull out is an x because they both have an x in it. In this case, I'm going to pull out a negative x because they are both negative terms. So step 4, pull out a GCF, pull out a negative x, you're left with 2x plus 9. What I was showing down here, I will erase this in a second because it's kind of confusing. But basically, when you have two factors that are equal to 0, if either one of these factors is 0, then the whole thing becomes 0. For example, if x is 0, this doesn't matter what this is, the whole thing is 0. That's what I was showing down here.
So you have to have the equal 0?
Yeah, you have to have the equal 0, yes. Well, it kind of came from the first step we did when we moved everything to one side. It's not like you have nothing on the other side of the equation, right? Like if you move everything over, you can't have a blank spot here. It's 0, right? Because you subtracted everything over. So that's why it's important. So we pull out negative x. Now we have two factors. You can see what's going to happen now. You're going to set each factor equal to 0 and solve. So the first factor is what you pulled out, that negative x. Set that equal to 0. The second factor is what's in parentheses, 2x plus 9. Set that equal to 0. So that's your next step. So now we're going to set each factor to 0 and solve. Let me go ahead and tell you this, guys. Your first factor that you pulled out, your GCF, you're always going to get x equals 0 back. That's because, like even if it was 3x squared equals 0, you would divide by 3, you still get 0. You would take the square root, you still get 0.
So no matter what, is it always going to be positive? Like that negative will always go away?
Yes.
So like...
Your left factor will always get you x equals 0 for this lesson.
So even if it had a variable in front of us, like let's say that you pulled out like a negative 4x, it would just turn into
It's still,
positive 4x?
yeah, it would still just turn to 0 ultimately. Now your right factor, you just have to do a few things. Here you can subtract 9 from both sides, divide by 2, and you get x equals negative 9 over 2. It's fine if you leave it as a fraction. That would be negative 4.5 if you want to write it as a decimal, but it doesn't matter. So for this lesson, you will get 2 answers. Okay? Straight up, you'll always get 2 answers.
No.
Okay, next example. We have 3x squared plus 2x equals x. Again, the way that you know to do these steps is this does not have a constant term. Every term has an x in it. So move everything to one side just like we did before. I usually move everything to the left, so I subtracted x from both sides. And again, if you want to, you can combine that. You know that's going to end up being just 1x. Going to make sure your terms are grouped, which they already are. We're going to move on to the next one. Combine like terms. Like we said, 2x minus x is just x. So again, you can do that all in one step. Doesn't matter to me. And then, what are you going to do next?
Pull out
Good.
an x.
Pull out an x, which is, yep, that's correct. So you're left with x and then 3x plus 1.
Oh, I forgot one was there.
Yeah, you have to, yeah, because x times 1 is x, so you have to do it that. All right, then you're going to set each factor equal to 0. First one's easy, right? It gives it to you, x equals 0. So no solving needed. But like I said, that always turns to 0. It really doesn't even matter what you pull out. It'll just ultimately give you x equals 0. Second term, 3x plus 1 equals 0. This one's pretty straightforward. You're going to subtract 1 and divide by 3. You get x equals negative 1/3. Those are your
So
two answers.
The variable on the right, always the one on the top? Like whatever number is thrown over to the right? On those, because like you subtract 1 and then...
Right. So if this was like plus 4, it'd end up being on the top of the fraction. And you're right, and then that number would be on the bottom.
So the right number's always on top, and the left number's on top.
Right, and the sign will flip, right, because you have to move to the other side. So since it was positive 1, it became negative 1. Whatever this is ends up being on the bottom. If they're both negative, you could see that, like if this was negative 3x, it would become positive 1/3. All right, one more example. We'll be done today. We got 2/3 x squared equals 2x. We would subtract 2x. I'm not sure what I was showing down there. In a previous lesson, I was showing something. I'll erase it because I can't remember what I was proving there. So we'll just leave that part. So just subtract 2x for the first step. Okay. So there's no terms to combine or group because it's just this, right? All right. So next step is to pull out a GCF. I think that's the reason why I was showing that. So,
Holy cow, this is confusing.
yeah,
Oh, that makes sense.
there's a couple ways to do this. One way, I kind of want to show this a different way, actually. I tell you what, let's do it this way. This is the easiest way to do this problem. I think this will be less confusing.
Oh, I wrote the problem down wrong. That's why I was like,
Multiply the entire equation, the entire thing, by the bottom of this fraction. So if it was a 4, multiply everything by 4. Since it's a 3, we multiply the entire equation by 3. Now, the cool thing is it won't affect the right? Because 3 times 0 is still 0. But it will affect these two terms. The ultimate reason we're doing this is to get rid of that 3, right? So the first term is just going to become 2x squared. The 3's will cancel. But then we have to do the 3 times the 2x, which is what?
Wait, why wouldn't you times the 3 into the 2?
Well, you could. You'd get 6 over 3, which is just 2, right?
Oh,
So
okay.
you can cross cancel it. Okay? 3 times 2 is 6, so it's going to give you minus 6x equals 0.
So when they're cross canceling, will it always work like that?
Yes. So that's going to be a little bit better. We're just going to do the problem on one page. You already know what to do. You're going to pull out a GCF. So what's the GCF of these two? 2x. All right. And you're left with x minus 3, right? Set each factor equal to 0. So this factor, like I said, that it's always going to turn to 0. You'll see why in a second. And then set the other factor equal to 0. So even if on the left you divide by 2, you still see what? X equals 0, right? On the right, you'll add 3.
And then how do you like write them next to each other? Like, can you just?
X equals 3. Those
So
are
that
your
one
answers.
doesn't need a fraction if it doesn't have a...
Yeah, when you write your answer, just you'll have one will be x equals 0, the other will be x equals 3. Or x
and you
equals
just write
whatever.
them next to each other?
Yep, just write them next to each other and circle them.